Alright, so here we go again. It is topic 4, and I just sound like a game show host there, didn't I? Permutations, combinations, and some factorial stuff. Number 1 is really a factorial question. We like to call it an arrangement question. Order does matter when letters are involved or numbers are involved, like a combination. And what you want to do is it said the number of 12 letter arrangements, so it's 12 factorial. And that 3 factorial times the 2 factorial is counting up the duplications. There are 3 n's, and there happen to be 2 a's. Unless I missed any other duplications there, it's going to be that. Throw that in your calculator. Factorial key you find in math. Go over to PRB menu. I think it's number 4. Correct me if I'm wrong there. And you get your 39,916,800. So it's 39 mil there. A lot of combinations. With number 2, it's order mattered, so it's a permutation. And we use slots here. And the reason why I have a 1 in the first slot is it said out of the 10 people racing, Sally had to come in first. So there's only one Sally, apparently. So it's 1, and there are 9 people left since Sally's out of the race, out of the 10 people. One of those 9 came in second, and there are 8 left, and you multiply that out to get your 72. Number 3, it's a combination, and combination order doesn't matter. You know, order doesn't matter in committees and study groups, or if I don't say pick something first. So that NCR key is very useful there. And you find that in your probability menu as well. That might be number 3, 6435. The 15 represents the total, and the 8 represents the choose number. Number 4. This was a combination question with probability. You see, in the other questions we didn't talk about probability. That's why a fraction wasn't involved. Remember that probability is favorable over total. And out of the 20 marbles in the bag, 15 red, 10 blue, I think it was blue, and 5 white, it might have been black, that we want to pick one of each. So the 20C3 in the denominator of this fraction represents the total number. 20 marbles choosing 3. The 15C1 represents choosing of 1 red marble. The 10C1 represents the choosing of one of the blue marbles. And the 5C1 represents choosing one of the white marbles. You throw that in the calculator, and then you have your 25 over 38. Make sure you try and convert things back to a fraction. If you use your fraction feature of the calculator, when entering this in, it should return a fraction, unless it's not able to. So that's an example of combinations with probability. For number 5 was an example of permutation with probability, or order mattered. And again, I don't like that permutation key. I like to go with slots. Now we want, for the first slot, an odd. For the second slot, an odd. For the third slot, an odd. For the fourth slot, it's the leftovers, which happen to be even. And the ones that I have to choose from are 1, 2, 5, and 9, with 1, 5, and 9 being the odd. Want to see that? See that in 3D? Okay. So, for the first position I have 3. That's the 3 over here. 3 odd out of a total of 4 numbers. I used an odd, so I have 2 left out of a total of 3 numbers left. I have 1 odd left over here out of a total of 2 odd left. 2 numbers left, rather. And then the 1 is the 1 left out of a total of 1 left. So you can see probability is favorable over total. You just take each slot in the order in which it comes. You multiply those across, and you get your 6 over 24, which is 1/4. You also could have written 0.25. I prefer those fractions when it comes to probability. You can express probability as a fraction, a decimal, or percentage. Either is acceptable. Usually reserve the percentages for statistics, but it does work.